In question 3, we're asked, relative to the graph of y equals 3 times the sine of x, which would have the sine function with an amplitude of 3, what is the shift of the graph of y equals 3 sine of x plus pi over 3 units? And remembering how pi over 3 units is the same as 60 degrees. Since x is being added to pi over 3, we're moving to the left. Pi over 3 units. If it was subtracted, it would be going to the right. And whenever the change is in parentheses, it's the horizontal change, which is going to control left or right. Up and down would be the vertical change. This horizontal change could also be referred to as phase shift. Which equation is represented by the graph shown below? Our amplitude is going to be 1/2 because that's the height, the maximum height of this function. So choice 1 and 3 are the only ones remaining. And then we're going to have to look at the period of this function. If we start at this y-axis, it's a cosine curve, and it's going to complete itself. By the time it gets to pi radians, it completes one full cycle. The time that it takes for one full cycle to complete is known as the period. So the period is pi radians. We know the formula for the period is 2 pi over b, and this is equal to pi over 1. We're going to cross multiply to solve this proportion. Pi times b is equal to 2 pi times 1, which is 2 pi. To get b alone, divide by pi on both sides of the equation. B equals 2, making our answer choice 1. The graph below represents the height above the ground h in inches of a point on a triathlete's bike wheel during a training ride in terms of time t in seconds. Our input is the time in seconds, our output is the height above the ground in inches. Identify the period of the graph and describe what the period represents. So if we're starting at this maximum point, which is we're starting with, before they even start the race, 0 seconds, the wheel starts at a position of 26 feet above the ground. And it's going to get back to that same position after one full cycle of this bike wheel. And that's going to happen at the period, which is the amount of time it takes for that cycle to complete itself. If we start at x equals 0, it's going to take 2 pi, it's going to take 2/3 of a second to get back to that same position. The depth of the water of a marker 20 feet from the shore in a bay is depicted by the graph below. The input would be the time, t, and the depth of the water, d, would be the output. If the depth d is measured in feet and time is measured in hours since midnight, what is the equation for the depth of the water at the marker? We're going to have to first look at the amplitude, which would be the highest value minus the lowest value. We're counting here by 2 as the interval, so this lowest value would be 4. 6, 8, 10, 12, 14 is your max. So we find the amplitude by taking 14, which is the max, and taking away 4, which is the min, and dividing that in half. This is going to work out to be 10 over 2. The amplitude is 5. We could eliminate any choice of an equation that doesn't have an amplitude of 5. Also, choice 1 and 4, which are remaining, both have the same frequency value, pi over 6. And that's multiplied by the input t. So the difference really comes into play as to whether this is a sine or a cosine function. Normally, cosine functions do not start at the origin, and they behave in a similar way like this graph is. However, we have to consider how there is a vertical change happening here, and we know that in the equation because I'll show you in green. In both of these, we have a plus 9 at the end, meaning that we went 9 units up. So if we start at 10, that's after translating it from y equals 1. I'm sorry, that first value actually is halfway between 8 and 9, 8 and 10, so it's 9. So it's going to start at the origin if it goes 9 units up. It started at the origin and went up 9 units up to 9. Therefore, this graph originally started at, before the vertical shift or translation, the graph originally started at the origin, meaning that this was the sine function. Cosine functions start at the maximum value, whereas sine